Well, hello and welcome to thermodynamics. Today we're going to be looking at Rankine cycles, and I love Rankine cycles. So let's just get right to it. So a Rankine cycle has four basic parts. Now, if you take an advanced thermodynamics course in Rankine cycles, we will get many more parts. In the basic cycle, we have a boiler, a turbine, a condenser, and a pump. This gives us four H's, a given pressure and temperature and so on at point 1 right after the boiler. Point 2 would be right after the turbine. Point 3 right after the condenser. And point 4 right after the pump. Now, as we have undoubtedly shown many times in the thermodynamics course, if you're watching this video during the thermodynamics core, we transfer heat into the working fluid. Working fluid in a Rankine cycle is typically water, but we do that in the boiler by burning coal. The turbine turns a shaft and can do external work. So we have heat transfer in, mechanical power by, and then we need to transfer heat out in the condenser. And in an advanced Rankine cycle, you would discover why we have to do that. Finally, to increase the pressure, we do mechanical work on. I'm doing everything here with dots, remembering, of course, that a dot, like W dot, is the change in H. So if we're going to do W dot by, it's the change in H, change in enthalpy. So if we're doing the turbine here, it'd be H1 minus H2 times the mass flow rate. Both equally important that we do have a change in energy, but then how much steam is going through the turbine will determine what the horsepower is. All right, well, the best way to visualize any cycle is on the TS diagram. So I will draw a TS diagram here. The pressure, there are two pressures we consider in a Rankine cycle. A high pressure, and the pressure gets high as you go through the pump. So as you go through the pump, the pressure goes from low pressure to high pressure. And then as you go through the turbine, it comes back down from high to low. So when modeling this, we only look at those two pressures, the high pressure and the low pressure. On the TS diagram, we're comfortable knowing that the high pressure is above the low pressure. Well, let's go to point 1. Point 1 is a high pressure. It's steam. That was the whole reason for having the boiler. And it's typically very much a superheated vapor. What you don't want is you don't want hardly any of the fluid when it goes through the turbine being in the vapor dome. When you're in the vapor dome, you get these little droplets of water, and little droplets of water traveling at very high speeds in a turbine cause damage to the turbine, vibrations, all sorts of bad stuff. So you want the exit to the turbine to be at best just way down here in the far end of the vapor dome. So point 1 is a superheated vapor. We would use the superheated vapor tables. We would be given the pressure and some temperature. Point 2 is straight below it. If that doesn't look straight below, it is. And I'm drawing it on the vapor dome, but don't confuse that. The way to go from point 1 to point 2 is to find the S at point 1 from the steam tables, and then come down to your low pressure, and S2 is equal to S1. It may be to the left of the vapor dome a little bit, it may be to the right of the vapor dome a little bit, it may be on the vapor dome, but it is directly below here. If I just tilt my paper, there we go. Now we've got it directly below. So let's talk about what's happening in that turbine. The pressure is dropping. The temperature is dropping. And energy is being extracted from the steam and converted to turning of the shaft, so the enthalpy is dropping. So in the turbine, all three things are going down: temperature, pressure, and enthalpy. Now, one thing that is going up is the specific volume. We often use the terms steam expands through the turbine, and expansion. Expansion means volume going up. All right, so that's the turbine. Next is the condenser. And again, if you take an advanced Rankine cycle, we will talk about why this has to happen, how it happens, and so on. From a cycle point of view, it has to happen because I need to get back around to this point. And to get back around to that point, I need to decrease my entropy. So point 2 to point 3 is the condensation, condensing, taking the vapor and turning it into a liquid, thus the name condenser. What's happening to the temperature? It's staying the same, can't you tell? There we go. Temperature is staying the same. Pressure is staying the same. Quality is going from high to 0. So point 3 is going to be a saturated liquid. Point 3 will be a saturated liquid. So S2 equals S1. I see that that was below my line, and point 3 is a saturated liquid. Again, the energy is lower. So if we were to sort of start ranking these, H1 would be high, H2 would be lower, H3 would be lower still, okay, that's the condenser. The purpose is to decrease the entropy. Point 4 is straight above point 3 at the high pressure. So when you increase the pressure, the temperature does go up with it, but not much. This is exaggerated. The temperature does go up with it. The enthalpy does go up, though when we start doing these problems, we'll see not very much. And so this is the turbine, this is the condenser, this is the pump. There's a special way to find H4. Finding H4, I in fact will complete this video and then do a quick video on how to find H4. And that's what the pump does. Its primary goal, increase the pressure. All right, then for us to complete the cycle, we have to get from point 4 to point 1. We know that as we move across the vapor dome, entropy goes up, energy goes up, pressure is staying the same. And we've calculated the area under a TS diagram before, and we know that that is heat transfer in. So we bring the H back to H1 in the boiler. Key word here, the cycle. This means it returns the fluid to its original state. Now, state is a collection of the properties. So it's the pressure, it's the temperature, it's the entropy, it's the phase, it's the specific volume, it's all those things. And as we go around the cycle, those properties change from point 1 to point 2 to point 3 to point 4. And when we get back to point 1, we have the same state again. This is a Rankine cycle operating in steady state. What does that mean? Steady state means that over time, everything at point 1 stays constant. The enthalpy at 1 stays the same. The enthalpy at, the pressure at 1 stays the same, and so on and so on and so on, all about point 1. Now, point 2 is different. It's got different enthalpies and pressures and temperatures and entropies, but they stay the same with respect to time. So this is a Rankine cycle. You'll find these in a power plant. You'll find them on a ship. It's where you use water to convert the energy of coal or a fuel into enthalpy of the water. High enthalpies. If you're in the core thermal class, we will do some sample problems and we'll find these enthalpies at each of these points. All right, that's it. See you in the next video.